Welcome to the NewSpace India podcast, a bi-weekly talk show that exclusively captures insightful conversations with people contributing to advancement of space activities in India. The NewSpace India podcast is pleased to announce our association with Dassault Systems, a global leader in providing business and people with collaborative virtual environments to imagine sustainable innovations. Dassault Systems Solutions support startups, small and medium-sized enterprises, and original equipment manufacturers in developing disruptive solutions for space launches and satellite propulsion. Hi, and welcome to yet another episode of the NewSpace India podcast. And we have here Anirudh, who's the CEO of Digantara Space. Welcome, Anirudh, to the show, and thanks for taking the time.
Thanks, Narayan, for having me here in this podcast.
Great. So let's rewind to some of the early days of your own personal journey and your team's personal journey before we actually get into Digantara itself. So tell us a little bit about your background and what got you into space and what led you to this space entrepreneurship path.
Okay, so it was back then in 2017. When there was the buzz around Isro student satellite program in different universities. IIT Bombay was building Pratham at that point in time, and there were students from SRM building SRM Sat. So that got me, interested in working on this domain. And before that, I always wanted to pursue my journey in the space domain. I wanted to take up aerospace engineering, but then due to peer pressure, I had to pursue computer science engineering. And I had one of my school friend who is today our CTO, Tanveer. So he was building a student satellite in his college, which is RV College of Engineering, Bangalore. And then we just had a casual conversation. At that point in time, I thought, why not I start this project or program in our university? So that's when it all started. But initially, it was really difficult for us to get some funding or to get this started in the university, because as university students, or say 17, 18-year-old, it's really difficult for us to convince the university administration to fund us for something like a satellite. So initially, we started participating in a lot of space conferences. One of the first conferences that we attended was from Isro. Actually, Semiconductor Laboratory and Isro, together organized a conference in Chandigarh back then, 2017. It was called National System Engineering Conference, where we presented a paper on nanosatellites. So basically, in the North Indian region, we have a problem of smog in the winters. So we just made a small research paper around smog detection using satellites. So that was our first paper that we presented, in a conference, for which we won a Best Student Research Award from Dr. B. N. Suresh. So that got our university, administration a bit of. They started taking interest in what we're building. So I think that's when they said, okay, fine, we'll support you in terms of the infrastructure in case you want to develop something. So let's start from building a ground station first rather than building a satellite. So that's when I and my partner Rahul Rawat, we started a team in the university. We had to recruit people from different engineering disciplines. So as a student club, we started this project. And then we had more than 60 students from different disciplines, like they are coming together and working on building a satellite. So post that, I, as a project manager to this team, so I had this responsibility of connecting our club to, the international organizations or people who can support us, basically. So that's when I wrote a lot of cold emails, more than 300, 400 emails, in which I got few replies back. And in that was one of the space agencies from South America. So they started working with us in terms of guiding in what we should do and what we should not do. So that's when we started working on ground stations or satellite systems. Then what happened is that at one point in time they asked us to develop a satellite structure because they couldn't get that from the US. So it was too costly for them to get it from the US. So a CubeSat structure, basically. So my dad works at DRDO and he knew a lot of them in Bangalore. So we just wanted to, search for vendors here. And then we had a team to design this, one new CubeSat structure. We designed it. Then we got it manufactured here in India and we exported it back to them. So that was our first freelancing project that we did, for which we got $1,000 check, and they asked us to provide an invoice. So just to provide an invoice, we had to start a company actually. So we didn't know what to do. So we started a company with no other aim than to provide them an invoice, because we were getting $1,000, and in India to start a company it takes $100, right? So that was our thinking, and that's when we started Digantara back then in 2018. And post that, we got a lot of opportunities and participation in a lot of conferences. In 2018 we were in Bremen at IAC. In 2019 we went to IAC again in Washington DC. In Washington DC we were listed as one of the top 8 startups for presenting our startup there to the international space community. So that's when we understood more about the commercial essence of what we were building in terms of the space traffic management. Taking a step back, right? So how we came to the conclusion that we should work on space sustainability or space debris or space debris management. So, when we were working with a South American agency, so they lost their first satellite due to a debris hit. And that's when we started working around what are the current available solutions in the industry or the market. So all were ground-based solutions. It was either radars or telescopes. So we wanted to build something much more sophisticated and efficient. And every time I look at the space traffic management, I always draw similarities to the aviation sector, the air traffic management systems that we have today. That is, the core of the air surveillance today in the industry. So we wanted to build something in that line. So that's when we started working around a solution, and we patented the current solution that we are building at Digantara, and we got our patent granted as well. So that gave us a bit of initial confidence that we can take this commercial. One of the important problems or one of the major problems that we had was funding, because space requires a lot of money. When we started working initially, so we had a lot of angel investors from Punjab region when we were in university, who said that okay, we'll fund around 10 lakhs, 20 lakhs, but that doesn't cut a slack for building something like this, right? So we started working around a lot of opportunities here and there, and we had to learn business, because in 2019 IAC we learned that there is a commercialization aspect to what we were building, and we have to take this product to the industry so that we can solve the problem that is faced today by the space industry. So we started talking to the fellow space startups here in India. Then we got to know the avenues that are available for a startup to grow. So that's when we got incubated at the Indian Institute of Science, and we got our first government grant from them, which was around 25 lakhs from the incubation team and 15 lakhs from the MSME Center of Excellence IISc. So that was our initial funding that we received for us to start a mission or build a prototype, a tangible prototype here in India.
Excellent. That's a very interesting journey overall. As you said, going from a university setup to like doing this professionally is quite a big arc. At the end of the day, that's actually one of the massive arcs that anybody can take at the end. So I know that a lot of university CubeSat teams struggle with the lack of support or lack of funding and lack of overall infrastructure needed to actually build up the whole program at the end. But then to having come to a conclusion that space traffic management is something that you want to do, and in such a short time, and trying to do all of this is actually very it's terrific, fantastic work at the end from your part, right? From your team part. I'm very. I would be in your stage, even when I was trying to kick off a venture coming out of university, I think I was also a bit lost out of all of this. And you seem to have, I'm in awe because, I've taken a lot more time in coming to a conclusion as to what is the venture and how to commercialize. And you've done all of this, I think your generation of entrepreneurs who have come up, either Bellatrix or you or Pixel or whoever it is, I think you guys have learned stuff very, very quickly than, maybe my generation, which is maybe one generation behind at the end. So this is also the reason I think, I'm very enthusiastic about young people starting up, but I'm sure that, it's as difficult or even more difficult with all the noise that is all around. So from your perspective, what was the journey like from going from this university setup where you probably were struggling to get all of this to then saying STM is the thing that we were doing? So what was the story behind, or why did you come to a conclusion that STM? Because you could have done anything. You could have done remote sensing. You could have done communication. You could have done rockets or whatever.
Right. So one of the major challenges that we had as a university team, and coming from, say, a tier three university, it was difficult for us to convince people. Actually, we so we had a long journey there, right? So initially, what we did was, when we started developing this product, it was totally towards the university student satellite program. And when university said that it's difficult for them to fund so much, that's when we still wanted to pursue this particular product that we were developing. As engineers, we were biased towards what we were building. So one of the important things that we did in our journey is to grab every opportunity that we got, even be it a competition which was giving you a grant of, say, 10,000 rupees, to a competition which was giving 15 lakh rupees in grant. So we participated in each of these things, and that's how we started accumulating some funds for building what we are doing today. And when we were thinking about commercializing this particular thing, that is the STM concept that we are developing, it was more or less towards the main reason is that we were biased towards our technology. Even though we did not have any commercial angle to it, we just wanted to pursue this opportunity. So that's where I think all the conferences that we attended and the knowledge that we gained there helped us to build a business model around it. And the timing was actually perfect for us, at least when we started in 2018 as a company. Space debris was not the talk of the town, at least in the space industry. In 2019, 2020, it became an headline in all these space channels or journals, right, because of the International Space Station maneuvers and stuff like that. So all this timing and the growth in the space activities helped us to build this business model. Rather than an internal push from our team, I would say that it is the ecosystem that supported us to grow, right? So supported us to work towards space traffic management, because back then in 2018 you never knew about Starlink would launch, say, 12,000 satellites, or Amazon's project Cupier, and stuff like that. It all happened recently, and we started back then with a product with no aim to commercialization. And now we have a product that is ready to commercialize in the space industry, because there is a requirement for what we are building. So that's how I think we chose this domain. And there were very few players doing this in the market at that point in time. And we were one of the very few companies who got a lot of traction in our initial days, even with just an idea. So that kept us thinking that, okay, when we are getting so much traction, when we just have an idea or a PowerPoint presentation, what we can do when we have a product. So that's when I think we started working around this concept, and I started building a business model around it myself personally, and took lessons or applied for a lot of these B schools, accelerator programs, and that's how I learned business the hard way.
Yeah, fantastic. At the end of the day, I think most of the teams that I've seen, of course, everybody doing business at the end has some engineering background. It always helps, right, to have some technical knowledge combined with the power of actually doing business at the end. So you all need always, different skill sets, of course, within a team to kind of succeed at the end. You said that you did get some support from all of this and so on. So now it looks possibly in retrospective in a different fashion, because you've gone on to raise venture capital funding or so on. But then to create that initial spark in people to kind of identify your idea and identify your idea as even worthy of a company, and being young is perhaps very difficult in a country like India. So who are the earliest supporters you think are somebody who you think helped you really, really well, and perhaps even IISc where you're incubated or so on? So who are your early supporters, and how did they actually help you?
So I would give this, or rather, I would put it in this way: our early supporters, one of the major support that we got our initial days was from our university itself, right? So when we started our ground station project, our university funded around 60 lakh rupees to build this ground station in the university. So with that funding, when we were in the university, one thing that I had in my mind was we just have 1 year left. So I was in my third year of my engineering. So once you complete your fourth year, you're done and you should get a job, right? So we had 1 year to experiment with what we are doing right now. So I think in the third year of our engineering, more or less, we spent a lot of time on developing these systems because we were funded by the university. So I would give this credit to the university that they supported us in the initial days. And then later, when we had to go commercial or when we had to build this as a venture, one of the important support that we got was from the Indian Institute of Science, Ministry of MSME, where they funded us 15 lakh rupees for us to build a small prototype and demonstrate this technology. And then it took us time to get incubated at IISc, because it's a long process actually, but they evaluate you both in technical business terms, commercial terms, and then they give you an incubation support. That's when we got our funding from IISc, which was around 25 plus 15, around 40 lakh rupees we had in our banks for us to build something. So we hired a small team, and that's how we got it. We got this started.
From that journey, that initial seed funding that you received or so on, I know that you possibly now have a patent, and maybe your technology, you cannot talk much deeper into the technology. I don't want to push you in that angle as well. But what is the baseline of STM or space traffic management that you are plugging into? So as I understand it, you're not into active debris removal, you're more into the tracking of the debris and so on. So just for listeners' sake, why don't you just walk us through what is space traffic management and what are different players doing in it and how you fit into that ecosystem?
So the first thing about space traffic management, or space domain awareness or space situational awareness. So these are the three terms used widely in the industry for debris tracking or object tracking in space. So the this was started by the US and Russia, where they were using their telescopes and radars to track space objects. SSN networks were there, space surveillance networks were there, established for them to track the active satellites or even debris about 10 centimeter in size. So that was the initial infrastructure available. And then what made it a necessity to build a commercial solution for this problem is that the increased amount of space activities or new space actors coming in the industry and launching more and more satellites. And the current infrastructure that is available today is just radars and telescopes. As you see that they are a static system, right? So they have a lot of limitations. So one of the major limitation is atmosphere, due to which they cannot track objects less than 10 centimeter in size, or up to certain extent they can track objects. So one of the major pain points that we wanted to address here is the false positives that are there in the industry, right? So currently, people might tell you that you need to maneuver your satellite by, say, the US data tells you that you need to maneuver your satellite, but that might not be the case in space actually, because you are not sure if the data is true or not, and you end up maneuvering your satellite, you lose your fuel and your operational costs. So we wanted to build a catalog which has a global acceptance, or we or merge these sensors that are available in the industry, see sensor data that are available in the industry, and provide an accurate solution in terms of space traffic management or space situational awareness for both commercial and defense stakeholders. So what we at Digantara are doing is building a space-based sensor system for us to be able to track these resident space objects much precisely than it is today in the industry. So with our systems, we can go up to 1 centimeter in size. So this will give us a room to track more than 900,000 objects than what it is today in the catalog. So this is the first thing. And the second thing is that, when we started doing this, it was really difficult for us to think around where we can fit our solution in the market. So that's where we started talking to more commercial customers or space stakeholders. That's when we understood that mission operations or mission management is one of the pain points in the industry. So people know how to build satellite and launch satellite, and what after launch is still there are a lot of new space startups which are still are not able to figure out how to do it. So that's where we wanted to fit our solution in, or provide APIs for their mission management using our data that we generate from our satellite constellation. The reason we are launching a constellation of satellite is to cover the entire lower Earth orbit with no blind spots and provide near real-time data in terms of these space situational awareness or space weather. The reason we are doing space weather right now with space situational awareness is because with space weather data, we can increase or enhance the accuracy of the data that we generate. Because currently in the industry, a lot of the current players use historical space weather data that are available into their algorithms for them to be able to predict the course of the object. In our case, we have built again a patented sensors with which we can understand the radiations in space and give that as an input to our algorithms or the data that we have generated, and make it much more precise than it is in the industry. So that's where we come in. So what we provide as a solution to a commercial space industry is an entire life cycle support for a satellite mission, from orbit selection. Because for example, we have come across a lot of folks who want to build satellite for X reason. Say assume that they want to build satellite for a remote sensing purpose, and the first thing that they will look at is what is the resolution that I need, or which orbit should I place my satellite to get or achieve this resolution. So the first thing that we wanted to do there is help them select their orbit based on the data that we have generated. That's orbit selection. And then comes orbit determination once they want to launch their satellite to the orbit, find the trajectories for launch. And then once the satellite is in the orbit, for satellite operations, we wanted to help them in terms of designing maneuvers. Or say a customer is launching a constellation of satellite, one, a subscription based system or a platform that can take all the satellite constellation or all the satellites as an input, and for them to be for them to optimize this data in terms of their satellite operation is what we wanted to do with our platform that we are building right now. That's in the operational side of things. And next thing comes deorbiting or end of life, where we can help them design the trajectories for deorbiting. So we are covering an entire life cycle for a satellite mission that way. Apart from these commercial stakeholders, we were also looking at insurance industry, because for insurance industry today there are not many products available around in orbit satellite insurance. The reason that is not available today is because the lack of data. So when you have to do debris removal, the first thing that you should be doing is understanding what is happening in the orbit, that is astrodynamics. So when you don't do that, removing say one or two objects doesn't make a lot of sense. When you are going into debris removal, you need to go as a whole solution to help resolve this problem, rather than going with say removing one object or two objects which are in your focus. For you to do that as well, you need SSA data. So that's where we thought that SSA data is really important for us to be able to provide the solution to the industry. And secondly, this will act as a base for doing all these missions, say in orbit servicing to debris removal. SSA is the first step, and that's what Japan is doing right now, or Germany is doing right now, right? So we wanted to walk in the same lines. And apart from us, there are a lot of other players in the market, and there is a company based out of Canada called North Star Earth and Space, who is building a constellation of satellites for tracking objects in space using a passive system. So what differentiates us from the others that are there in the market is we are using an active system. Basically, we have our own source of signals for us to be able to track objects, be it day or night time. And secondly, the integration of space weather modules enhances our capabilities in terms of the quality of the data. And apart from the space-based solution providers, there are many ground-based solution providers. One of the good companies that I look at is Leo Labs, based out of the US, who is working with SpaceX right now and the US Department of Defense in terms of tracking objects, and they're expanding their radars globally in terms of providing an SSA solution to the commercial space industry.
Excellent. I mean, that's a really nice overview on all of this. So as far as your in constellation that you are trying to build now, and I guess the patent that you have is for the payload or the heart of the whole mission at the end. So what is your strategy with respect to execution now? Now that you've also raised this venture capital and so on. So are you looking to build it yourself, or because you're maybe are focusing on the execution side with the APIs and the payload, you want to have a partner build it and launch it for you? How is the execution roadmap for you guys?
Okay, so basically, initially we were inclined towards building our own satellite and plugging in our payloads and launching it. But then we wanted to prioritize on building this software and hardware stack for SSA, and rather than reinventing the wheel in terms of building all the subsystems ourselves. So that's where we started working more on the payload development, and for our satellites, so we are outsourcing our satellite development, where we can just plug in our satellite into the existing CubeSat form factors that are available and then launch it to space. So our strategy in terms of execution is that we're launching our first satellite as a technology demonstration mission, and we have certain parameters around it, where once we launch our satellite, we are tracking the objects that are tracked by the ground-based system, so that we check the calibration. So first mission is more or less a calibration come a technology demonstration mission for our payload. And once we finish our first mission, the data that we generate from our first mission, so we have onboarded few pilot customers who can consume this data. These are some of the companies who work in mission management and operations, and others are SSA software companies who intake data from different sources. So we are working with them in terms of understanding where exactly we can fit in our solution. So one of the important things that we learned hard way is that initially when we started building this, like I said, we were more or less biased towards what we were building. So we understood that we should not push this technology to the market, rather we should have a customer's acceptance in terms of the solution itself, right? So we started talking to the commercial stakeholders, took their inputs while building each component of our payload, so that we cover the entire requirement of a commercial customer that way. And secondly, when we were building this, we never looked at defense side of things, and defense is really interested in having an indigenous space based sensors or space situational awareness capabilities in India. So that's when we understood what defense looks at it. So how do they want the solution to be, and what exactly is the requirement? Because for defense, it's not about tracking debris, right? So tracking debris doesn't make sense for defense. It's all about space surveillance for them. You should be able to monitor other objects in space. So that's the requirement, which we can essentially do with our satellite constellation. So we had to work towards having a different data set for commercial and defense, while we are generating data from our satellite constellation. So currently, in terms of execution, we are more or less focused only towards building the hardware part of the payload and a software suite for this particular solution.
When it comes to what is the advantage that your customer gets out of your service, right? And can you walk us through what that exactly is? For example, because at the end of the day, there are paint-sized blocks of space debris that are affecting the space environment, where even a whatever speck of paint is creating holes in the International Space Station, where maybe we don't have the capability to actually track that paint, or I don't know if today they've already built such capability, right? So there's of course various sizes of the debris and how they are tracked, and how manures can be taken up and so on. So both from the sense of size of the debris, as well as perhaps how much time can you give somebody to actually move their asset to be safe or so on. And so can you walk us through that part of how this would work?
Okay, so what we're doing commercially is that, like I said, we provide a lifecycle support to a commercial satellite operator. So that way, once your satellite is in the orbit, what we do with our satellite constellation is that the data that we generate from our satellite constellation, we build time advanced models of these objects. And in case there is a debris that may hit your satellite, or if your satellite is in the verge of collision, uh, prior to that, say in 72-hour time span, we will provide you a maneuver designs or maneuver alert for your satellite once you are a part of our subscription service. So that's how we help design maneuvers and also help you in terms of your satellite operation itself. So more or less, we provide these time advance model, which I call it, or which the industry terms it as orbit propagation, by which we generate these models and then provide this to a commercial customer. So the value that we generate to a customer is to help them save their operational cost, not only in terms of maneuvering from space debris or space junk. So it is more or less focused towards satellite operation itself, be it in terms of optimizing a constellation, understanding its coverage, and stuff like that. Right. So space situational awareness data has different applications, or this has different elite applications that this data can be used for. So that's where we started focusing towards satellite operations rather than focusing on just the debris side of things.
Right, interesting. And from your perspective, do you think that this whole space traffic management will now, because of space tourism or all of these remote sensing constellations or communication constellations, these are the main blocks, or and also will LEO still remain the core part of the interest for the next few years, or do you see this extended towards MEO and GEO as well?
One of the things that I wanted to mention here is that space traffic management is really important to the space industry at this point in time, where every enterprise is looking at launching satellites or some or the other way leveraging space technology in their businesses. So, including space tourism. So, this for space industry to grow or space economy to grow, there are a lot of innovations that are happening in the industry today in terms of in-orbit manufacturing, in-orbit servicing. For all these activities, one of the major concerns that they have is how do we manage this, because space is a common resource, and there is no jurisdictions there as such for anyone to control. So one of the important things that is necessary in space is transparency and coordination. So if transparency and coordination is there or are there, that will help space industry to cherish and grow. So in that lines, what I would say is that a LEO orbit would still be the orbit in demand for all these communication remote sensing satellites. As technology improvises, I think there could be a change there where people might look at MEO orbits as well. But right now, looking at the boom in terms of space tourism, in terms of the satellite communication constellation, remote sensing constellation, LEO will still be the orbit of choice for all these new space actors or space stakeholders for them to deploy their satellites. And a lot of them right now are working towards, say, refueling and many interesting technologies in terms of docking, etc. So the core of all these is again space situational awareness. So in this way, I'm just trying to communicate how important is space situational awareness or the data of what is happening in the orbit. Just to give you another similarity, on grounds we have already polluted a lot of stuff, right? So we know what is happening here, and there is traffic management systems, be it on ground, be it in air. But such a solution is required in space as well, for us to be able to coordinate with countries. In ground you have jurisdictions for you to control that, you have airspaces to control that. How do we solve this problem for space? And a commercial entity has to government has to do it at first point. But government right now in the US, actually what they did is they transferred the SSA uh, the SSA capability itself to from Department of Defense to Department of Commerce, in terms of helping all the US based space companies to commercialize or enter into the SSA domain and provide civil space traffic management solutions or systems. So in that lines, I think a coordinated effort is required from the industry for us to solve this particular problem so that the industry can grow.
One of the aspects that I would love to hear from you is also the commercialization part of it, because I know that I mean, I have also had an Indian company, started a company in India and tried to build a company, sitting out of India. One of the aspects that I experienced during my time, at least in India, is that once you said that you were an Indian company, a lot of the Western customers, they try to hard negotiate prices, saying, "Oh, you are an Indian company, you have to do it 10 times cheaper than us because you have, lesser cost of manpower and lesser cost of infrastructure and all of these." So when you were starting to negotiate a lot of this, I know that your customer base is primarily outside of India at this point of time as well. So did you face any such problems? What were your key learnings as a part of the journey?
So in our initial days, like I said, we started developing satellite subsystems, say structures, avionics, and stuff like that, right? So at that point in time, we had this problem, and we had to negotiate for the prices that they were telling us to do, because we had no other go to establish credibility in the industry. Because you need to sell a product in the space industry for you to be able to build your company as a brand. So that was our initial learnings that we had while we were developing hardwares. But the current solution that we are providing is more or less focused towards data. So we as a company are owning infrastructure and space for us to generate data, and this data is something that we sell, right? So now that SaaS industry in India is much more established than space industry, so we don't have such hardware related problems in terms of price negotiations in this domain, at least. So we are competing with the global prices that are there in the industry today. So our pricing is much similar to an insurance premium. It depends on the class of an asset, basically. So if your satellite is say 100 kgs, our pricing is according to your satellite's class, rather than a fixed pricing.
You are one of the companies that have today raised venture capital among other companies that are in India as well. 10 years ago this was a very difficult landscape because having even angels give you any money in space was very difficult in India at that point of time. So, and it's now massively changed where you all have some sort of a FOMO within investors to pick right companies and investing in India. So what has been your this private equity or venture capital investment journey so far, and how did you finalize on I think Kalari Capital is the one who is now funding you guys. So did you also have to educate a lot of the VC community and so on? Because when I talk to Pawan or Srinath or others, they would have told me that I've spoken to 150, 200 investors before we've got our money, right? So it gets progressively easy because they've actually done some education in the community over time, and more and more companies may have it easier for them because it may not take them 200 meetings, but maybe 20 or 30 before they get an investor.
So one of the major things that I would like to mention here is the timing, right? So the timing is really perfect, is what we feel internally, right? So in the era of commercialization of space activities or human space flight, where one of the three richest people or space junkies, they are space junkies actually. So they are moving towards or giving ads on commercializing the space, or Richard Branson's human spaceflight. So this is creating an awareness and among the investor community, and general public is understanding the importance of space. Or they're before in my childhood, at least, if someone says space, it was just Isro or NASA, right? So today it's not that. So it's like it's much more beyond than Isro and NASA's or SpaceX right now. It's more or less like space tourism is no more a dream. So in that way, a lot of these investors are getting educated about this sector, and they feel that this sector is something that they should invest in, and that this is an inflection point for them, or for the industry, where this can turn something like the IT revolution. So when we started our fundraising initially, so we had again, we had to speak to a lot of venture capital firms, the angel investment firms here in India. We spoke to more than 40 investors or 40 investment firms in India before we finalized our investment. And one of the important things that we learned while we were fundraising is that how do we sell our dreams, basically, in terms of building a conviction in terms of the venture capital. Because in space industry it's different, said it's different, right? In the other industries it's just like you have an MVP, and then you go to them saying you have this much traction, so many customers and stuff like that. But in this industry, you need money to build an MVP itself. right? So your initial game would be to build conviction in them, and one of the most important things that you should be doing is educating them while you're building conviction in them in terms of what you can pull and what you cannot do. So when we started doing this, initially it was tough, but looking at the ecosystem or how it is growing, people started knowing that there is a market for what we are building, because every other day you were seeing news about space debris concerns in the in few journals or articles like that. So uh, when we finalized our funding, we as engineers didn't know much about finance. So I give this credit to Kalari and team, where they supported us in terms of building the entire financial model for us. Sat with us for a few weeks, and we developed this entire commercialization model or financial models together. I think that's how a VC should be, because VCs cannot expect an engineer to know everything in terms of say finance, business, technology. So they gave us our initial they were our initial support when we started raising funds from them. So they helped us in terms of understanding how a VC industry works and what do they expect from a startup. So I think this has helped us um, in our journey to get this seed funding.
What do you think about the local ecosystem in India, which is coming up with some other private companies who are also going to be operating satellites like Pixel, or some other companies that are planning to put out all of their spacecraft? Do you think that these companies, are interested in your services, will take up your services, or even perhaps that is one part of the question, right? And the other is, of course, is the system in India, including ISRO, willing to contract somebody like you who is coming up with such a novel concept? And I know that ISRO is, for example, put out a RFQ to procure data for 6 months for space situational awareness, and they're going to be contracting a foreign company procuring that data soon. And given that you're establishing some of this capability, what do you feel like? Do you feel like in the next 3 or 4 years, the ecosystem in India is not ready, even privately or publicly, and that you'll have to survive this by having foreign customers? Or how do you see this heading?
What I would like to tell here is that the local ecosystem is growing right now. I think we have a good market in terms of the launch companies or satellite companies willing to purchase this data. So we have interest from a few of the local companies to purchase our data as well for their satellite constellation. And when it comes to ISRO, right? So ISRO is currently working on building an indigenous system in India by establishing telescopes and radars in India for them to be able to track objects, for which they have put out an RFIs and RFQs in terms of procuring data, hardware for SSA. But it takes time for them to evolve. But one thing that we learned from ISRO is that when we were talking to them about the solution of ours, we didn't want to get into this ISRO at this point in time where we have not released our product in the industry. But we wanted to go to them with our entire solution suite. So that way, we applied for a challenge which ISRO had announced called Arise Anik, and the category 3 of the challenge was towards space robotics, AR, VR, and outer space monitoring technologies. And we won that challenge, and we've received a 50 lakh grant from ISRO. And we're working closely with them, and they're providing us all the support that we need from the organization in terms of the test facilities, or also in terms of intellectual capital. So we are also working with few scientists from ISRO who have worked in this domain before, say, in terms of trajectory optimization and stuff with inter-satellite missions or interplanetary missions. So that way, I think the local ecosystem is gearing things up right now, and this the market here in India can be ready for us probably by the time we start commercializing our solution in the market.
When it comes to developing a company like yours, you're really pushing the barrier, right? You're doing something that no other company in the country is kind of doing. And perhaps, one of the problems of that is to find the right people to join your team. So the people at Bellatrix, since I also know them very well, they were mentioning to me that once they put out 8 openings or so on, and they received some 9,000 applications. And sometimes the same person are applying for 3 or 4 jobs in that 8 list, right? So do you struggle a lot with finding relevant talent to then absorb into your company, and to have them fit into the requirements? What is when it comes to identifying talent and training them, what has been your experience so far?
So we just concluded our hiring, and we had similar problem that Bellatrix has faced. So we had 3 or 4 job roles, and people had applied for all four, and we had such cases, and we had more than 500, 600 applications which we had to filter. But what we did while we started announcing these jobs is that we had a filtering mechanism by giving them an assignment, right? So that assignment did not have any right or wrong answer. So we just wanted to understand a person's approach in solving a problem, an engineering problem. So that's how a lot of our internal management around hiring got easy. People used to just give up, and we have seen a lot of experts who gave up solving that particular assignment that we had given. So that was one of the things that helped us to shortlist people. But in India, we still face a talent problem in this sector. At least the sector that we are operating is niche, right? So there are not many universities or colleges providing courses around orbital mechanics, and there are very few institutes which provide these, right? So we had to reach out to the institutes and then ask them if they know someone who can they can refer us so that we can talk to them. So that was our initial hiring experience. And now that we have concluded our hiring from say IISc Bangalore, so I think in near future we will face this problem of talent shortage if India doesn't gear up, or Indian institutes do not start courses around all these advanced space technology learnings and stuff.
Right. Again, super interesting overall as such. So when it comes to a lot of the changes that are happening in policies at this current times, we have the draft space transportation policy, draft, remote sensing policy, and others as well. Is there anything that you would wish that changes quickly for you guys to then say it gets easier, our life gets easier, and this is something that policymakers should focus on to help, grow our certainty to our company and provide the stable regulatory framework?
Right. So one of the major problems that we have at this point in time is that there is no proper a transparent framework or policy for us to be able to register our satellites here in India. That's one. And the second thing that we have is around frequency allocation. So it takes a lot of time here in India for us to get this frequency allocation. At times, we have to apply this 1 year before our satellite launch for us to get these licenses before the launch. So these are the two things that we see as a problem at this point in time. But apart from that, coming specific to what we're building, there are a lot of policies in the US around space situational awareness data, which is not there here in India. And when we had discussions with few stakeholders, we had to educate them about what is there in the US, what is there in the Europe. So one advantage that I see is that we can drive the policy if the stakeholders cooperate. But I think if there is a framework around how we can share this data with the commercial space operators or with the military or with the other governments, if there is a proper framework around space situational awareness data, that will be helpful for us.
Yeah, that's absolutely great. So one of the things that I'm trying to collect from many of the younger space entrepreneurs is what can an industry association do in India. So recently there's been an industry association called the Satcom Industry Association, and they are trying to tell the government what are all the areas that they can work on so that policies can be framed very well and so on. So the other couple of ideas I had is having an industry association run events, for example, book places like common place for all the companies to then have a participation in a trade show like an IAC, or taking industry delegations to other countries where you can have prior meetings set up with potential customers to have time with them and so on. Do you think that there is any pointers in which this kind of industry association can help out in a greater fashion that will add beyond just telling governments these are the things that you can work on? Any other value adds do you think we can add to such a frame industry association?
Yeah, so I think trade fairs, like you rightly mentioned, is really important, at least for the local ecosystem to understand each other. There are a lot of companies here in India. So when we were looking at vendors or suppliers for few of our technologies, we had to search, and there are not many companies which are on internet per se. So you need there are a lot many companies who are currently Isro vendors or building advanced electro optics systems here in India, but we do not know them. I think building or organizing such trade fairs or conferences like IAC would help the local ecosystem to know each other and complement each other's solution, or help together is what I believe. But apart from that, having an association like you mentioned is really important, because that will act as a bridge and reduce a lot of our efforts in terms of reaching out to the government, because we have a channel for us to put forward our requests, and then they can take it to the government. And policy is the most important thing, I would say. If there is a good policy or a transparent policy framework in place, the ecosystem would cherish and grow.
Right. I'm going to put you in a spot by asking you a question, which is maybe tough. Given that you've gone through this journey now, and perhaps there's other younger people coming into the same journey and trying to find their way out, what do you think are the top mistakes that you did that other people who are following your footsteps can avoid?
So one of the major mistakes that we did in our journey is when we were trying to build our technology. It took us a lot of time, or I mean, in fact, we were trying to focus on building this as a business. And in our initial days, right? So we had an idea, but we did not really focus on building this technology. Uh, we took some time to get grants or money for us to build this idea. So, what suggestion or what advice that I give is that at this point in time, I feel that we should have done things much before than we are doing right now. Uh, the only reason is that at at many times what we feel is that we need money or we need resources to build this, but that might not be true. You may still have resources for you to build something, but uh, it's just that we feel that we don't have resources. So that was one of the major mistakes that we did in our journey, due to which we had a lot of delays, say in terms of, be it in terms of funding, be it in terms of building this prototype at the right time. We could have done it much before. So one thing is that never look for resources when you're building technology. You should look for resources, but what I'm trying to tell here is that never think that you don't have resources. You still can have an alternative way in terms of finding the solution for that problem.
Excellent. And what do you think ISRO can do to help companies like you and others from this point of time? Because we talked about already the policy changes. Beyond just the policy changes and giving you infrastructure and some of their experts, what else do you think could be done to support companies like you?
So I think one of the major things that has helped us is we got grants from the government initially, which was around 1 crore rupees, right? So in total, we have raised more than 1 crore from the government grants, without losing any equity, right? So that has helped us a lot in our journey. So there are a lot of avenues that the government has for funding. I think all the entrepreneurs, who are wanting to start a company in the space industry, should definitely look at such schemes that are available in the industry. Apart from that, ISRO's handholding is really important. But what I really appreciate is the European Space Agency's model of setting up the incubation centers. In India, again, we have incubation centers, but it is not like it is in the Europe, right? So ESA PICs are not there here in India. ISRO has incubation centers, which they call STCs and stuff like that, which are there in, say, IISc Bangalore, NIT Jalandhar, NIT Agartala. But I don't think that is functioning to the fullest or what they built it for. So if they follow model like how the European Space Agency is following, it will help a lot of entrepreneurs to get their initial funding, or to get their initial trigger for them to start something from that particular center, is what I believe. So ISRO will play an important role in building the local ecosystem here in India for the space entrepreneurs to grow.
Right. Final question. So, what do you think is the trajectory like in the next, 5 to 7 years for you as well as for the overall ecosystem? So we've seen, about 30, 40 companies come up across upstream, midstream, downstream in the sector in India over the last 5 or 6 years, right? So as far as your company is concerned, you see operating these 9 satellites or adding more satellites or so on. And then, from an ecosystem perspective, do you think we'll see, I don't know, maybe 50 more companies come up in the next 5 to 7 years?
So what we're trying to build here at Digantara is a basic infrastructure, something similar to what Google Maps did, right? So Google Maps, is a base for a lot of companies to grow. So we're trying to build a solution which is something similar to what Google Maps has done. But what we are focusing here, our vision is to build a surveillance company. Uh, uh, Leveraging space technology, not just in tracking space objects, but in other domains as well, as slowly we expand, say in the air surveillance, ADSB, and other sectors. So that way, I think I foresee something like Google Maps has done today in the industry here in India, in terms of the space ecosystem as well.
Excellent. And as far as the other companies are concerned, what do you think will evolve? Do you see that we'll have tens of other companies come up? What is your feeling like?
So, I mean, I just, I used to Google a lot of times how many Indian companies are working in space tech, right? So I've seen a lot of space companies wanting to build rockets. Apart from Skyroot and Agnikul, there are a bunch of companies in India who are trying to build rockets. And, I think looking at them, I feel that there is a lot of potential for Indian entrepreneurs to build something in the space ecosystem. It's just that they're not getting that recognition or support that they need for them to grow. For the years to come, I think there'll be, if the government supports in terms of their initial funding and in terms of handholding from Isro, there will be a change in the industry which is necessary for the Indian privatization of the space industry, is what I feel.
All right. So again, Anirudh, thank you so much for taking an hour's time. I'm sure that you're super busy with everything, and good luck to you and your team in all the progress. I think this is a very interesting idea, very interesting aspect of commercialization, and quite unique to India itself. So I definitely congratulate you and your team in the progress that you've had so far, and I hope you can truly become one of the leaders in this sector in the coming years, coming out of India.
Yeah, thanks, Narayan. Thanks.